The B-21 Raider stands as one of the most significant advancements in U.S. military aviation and strategic deterrence in recent decades. It is designed to replace the aging fleet of strategic bombers, including the B-1 Lancer and the B-2 Spirit, and to serve as the backbone of the Air Force's long-range strike capability well into the latter half of the 21st century. The evolution of threats, including advanced integrated air defense systems, long-range missile threats, and the need to project power globally with precision and stealth, has driven the development of the B-21. It embodies the Air Force's commitment to maintaining a credible, flexible, and survivable nuclear and conventional strike force. The first B-21, often called the engineering test aircraft, was introduced primarily to validate the aircraft's fundamental design characteristics. This phase focuses on ensuring the aircraft can safely and reliably fly across its intended flight envelope. This includes testing aerodynamics, control responsiveness, stability, and structural limits. These initial flights gather essential data that confirm whether the digital models and wind tunnel predictions made during the design phase translate accurately to real-world performance. This step is crucial because it verifies the aircraft's physical capabilities and informs any design tweaks needed to optimize performance and safety. With the first B-21 successfully flying and proving the basics of flight, the program then moves into a deeper and more complex phase, testing weapons integration and mission systems. This is where the second B-21 comes into play. Unlike the first aircraft, which carried specialized test equipment like flight test booms and trailing cones, the second B-21 is configured more like an operational bomber. It lacks those flight-specific sensors but includes advanced electronics and software that simulate real mission conditions. This aircraft is critical for validating how well the B-21 can detect, track, and engage targets, how it manages its weapons payload, and how it interfaces with other assets in a networked combat environment. The integration of weapons and mission systems involves more than just physically carrying bombs or missiles. It encompasses the complex orchestration of sensors, communication systems, navigation aids, electronic warfare capabilities, and mission planning tools. The B-21 must demonstrate the ability to carry and deploy a range of weapons, from nuclear gravity bombs like the B-61 to sophisticated standoff weapons like the AGM-181 long-range standoff missile. The standoff missile, in particular, enables the bomber to engage targets from great distances, reducing the risk to the aircraft and its crew by avoiding enemy air defenses. This is essential in modern warfare where adversaries are rapidly advancing their integrated air defense systems. Another vital component being tested with the second B-21 is the capability to use next-generation penetrator weapons. These are designed to destroy hardened targets, such as underground command centers, missile silos, or bunkers, which pose significant challenges to traditional munitions. The ability to neutralize these high-value targets is central to maintaining the effectiveness of the strategic bomber fleet in deterrence and combat roles. The B-21's mission systems also include advanced stealth technology, not just in its airframe design but also in how it manages its electronic emissions and counters enemy radar and missile threats. The aircraft's sensor suite and electronic warfare systems work in tandem to detect threats, jam or deceive enemy radars, and provide pilots with real-time situational awareness. This combination ensures that the B-21 can operate undetected deep inside hostile airspace and complete its mission even in the most contested environments. A key enabler of the B-21's future effectiveness is the sophisticated software architecture being developed alongside the aircraft. Northrop Grumman is delivering an enhanced software package that supports seamless upgrades throughout the bomber's service life. This software infrastructure allows for rapid integration of new weapons, sensors, and defensive systems, ensuring the B-21 remains at the cutting edge of technology despite the long service life expected from the aircraft. This digital adaptability is a game-changer compared to previous bomber programs that required costly and time-consuming physical modifications to incorporate new capabilities. Another advantage of the B-21 program is its production approach. The test aircraft, including the second B-21, are built using production tooling rather than unique, one-off test builds. This means the test aircraft closely resemble the operational bombers that will be delivered to the Air Force. As a result, any issues uncovered during testing are directly relevant to the fleet, accelerating the transition from testing to active duty. This manufacturing philosophy also allows for a smoother ramp-up in production rates, which is critical given the Air Force's desire to build at least 100 bombers, with the potential for expanding beyond that number to meet increasing strategic demands. Operationally, the B-21 will be deployed initially to Ellsworth Air Force Base in South Dakota. Ellsworth is well positioned to become the heart of the nation's strategic bomber force, benefiting from existing infrastructure and expertise. Over time, other bases such as Whiteman Air Force Base in Missouri and Dyess Air Force Base in Texas are expected to receive B-21 units, creating a dispersed and resilient bomber force that enhances survivability and global reach. This distribution supports operational flexibility and ensures the bomber force can respond rapidly to crises anywhere in the world. The B-21's role in the U.S. military strategy is more than just delivering weapons, it is a powerful deterrent. Its presence signals to potential adversaries that the U.S. maintains the capability to penetrate any air defense network, hold critical targets at risk, and respond swiftly to threats. This deterrence underpins national security and strategic stability, particularly in an era of renewed great power competition. Furthermore, the B-21 program supports the modernization of the entire strategic bomber enterprise, including training, maintenance, and support systems. The Air Force is investing in new simulators, digital training environments, and maintenance tools that complement the advanced technology onboard the bomber. These efforts ensure that crews are highly proficient and that the aircraft can be kept mission-ready with greater efficiency. The second B-21 test aircraft's role in testing weapons and mission systems is a pivotal step in the bomber's development. It shifts the program from proving that the aircraft can fly safely to proving that it can execute its core combat mission effectively. This phase verifies that the B-21 can integrate cutting-edge weapons, maintain stealth, operate in contested environments, and remain adaptable through advanced software. The success of this testing will accelerate the B-21's entry into operational service, strengthening the United States' strategic deterrent and ensuring air dominance for decades to come.